You may be aware that in the most basic electric circuit, you have three quantities that are usually present: the voltage, the current, and the resistance. In the previous video, I did a practical guide to Ohm's law. Ohm's law is a principle in electrical engineering that connects the three most fundamental quantities in an electric circuit: the voltage, the current, and the resistance. Ohm's law states that the current flowing through a metallic conductor is directly proportional to the potential difference across its ends. It can be mathematically expressed as V is directly proportional to I. If we keep the resistance in the circuit constant but vary the voltage, the current will also vary. We can also vary the resistance while keeping the voltage constant in order to vary the current. In a case where we know the value of the resistance and the voltage, we can determine the value of the current. This is given by I is equals to V all over R. Amperes. Take for example this resistor. It has a value of 324 ohms. I'm going to connect this voltage across it. The value of the voltage is 8.24 volts. By Ohm's law, we expect the current that is going to run through the resistor to be 8.24 divided by 324. This amounts to 8.24 divided by 324. This gives 0.0254. 0.0254 amperes, which is equal to 25.4 milliamperes. If we connect this up to a circuit practically, we get 22 milliamperes. With our calculations, we were able to predict an ideal value of 0.022 amperes. Well, practically we were able to get 0.25 amperes, but practically we were able to get 0.022 amperes. There's a little bit of deviation from the expected value because of, say, I square R losses, heat losses in the circuit. But we can see that we can estimate what the value of the current should be like. It is possible to have a high voltage and a low current when there is a very high resistance in the circuit. Take for example, if you had a voltage of 1000 volts and there happened to be a resistance of 1 megavolt in the circuit, one will get a current of 0.00 ampere in the circuit. It is also possible to have a low voltage but high current. Take for example, we have 1 volt. We have 1 volt applied across a resistance of say 0.010. The amount of current that will flow through this resistance will be 100 ampere, which is a very high amount of current. Basically, current is less with high current and vice versa. There's an inverse proportion between them. The amount of voltage across the resistor R must be equal to the voltage applied because it is connected directly across the voltage. So it swallows the entirety of the voltage applied across it. And this is given by V is equal to R. This is the second form in which Ohm's law can manifest. So if we need the value of a resistor, and we need the amount of current flowing through the resistor, we predict that the voltage across the resistor would be current times resistance which would give us 8.97 volts. If we go back to measure the voltage across the circuit, we get 8.92 volts. The third version of Ohm's law is R is equals to V all over I, which leads us to predict the value of the resistance knowing the V to I ratio of the electric circuit. The resistance is a physical property of materials, as we do not need to make a physical construction of a resistance to analyze its effects in an electric circuit. So as long as we know the value of the voltage and the current, we can predict the resistance. Take this circuit for example. We know the value of the current, that's about 0.09 milliamperes or 0.94 microamperes. The value of the voltage, which is about 9.48. Then estimate that the resistance in the circuit is equals to 9.48 divided by 95 times 10 raised to the power minus 6. This gives 99789 ohms. That should be around about 100 kilo ohms approximately. Measuring the actual resistance in the circuit, we get 99.5 ohms, 95.5 kilo ohms as estimated. That'll be all for today. Don't forget to like and subscribe. Leave your comments below. See you all in the next video. Thank you.